What if every human on Earth jumped at the exact same time? At first glance, it sounds like the kind of thing that might shake the planet. After all, there are about 8 billion people on Earth. If everyone jumped together, that's a lot of mass leaving the ground at once. But would it actually do anything? Let's find out. The average human weighs around 62 kilograms. Multiply that by 8 billion people, and the total mass of humanity comes out to roughly 500 billion kilograms. That's a huge number. But compared to Earth, it's not very impressive. Our planet has a mass of about 6 septillion kilograms. That's a 6 followed by 24 zeros. In other words, all humans combined make up about 1/10 trillion of Earth's mass. So even if every person jumped simultaneously, the planet itself wouldn't notice much. But what about the force of the jump? When you jump, you push downward on the ground. According to Newton's third law, the ground pushes back with equal force, sending you upward. If everyone jumped at once, we would briefly push Earth in the opposite direction. However, because Earth is so massive, that movement would be incredibly tiny. If all 8 billion people jumped about 30 centimeters into the air, the Earth would shift in the opposite direction by roughly a few trillionths of a meter. That's less than the width of an atom. Even the most sensitive scientific instruments might struggle to measure it. But the real question isn't what happens when everyone jumps. It's what happens when everyone lands. If 8 billion people came crashing back down at the same time, you might imagine the impact sending shockwaves through the planet. In reality, most of that energy would simply be absorbed by the ground beneath us. The total energy released by all those people landing would be around a few trillion joules. That sounds like a lot, but in geological terms, it's tiny. A moderate earthquake releases thousands of times more energy. So the Earth itself would be completely fine. No cracks in the crust, no shift in Earth's orbit, no global seismic disaster. But there is one interesting problem: coordination. For this scenario to work, all 8 billion people would have to jump at exactly the same moment. The Earth is about 40,000 kilometers around, and signals, like radio or light, can only travel at the speed of light. Even a signal moving at that speed would take over 1/10 of a second to travel around the planet. That means people on opposite sides of Earth could never jump perfectly simultaneously. By the time the signal reached them, everyone else would already be on their way back down. In other words, a perfectly synchronized global jump is physically impossible. But even if we somehow solved that problem, even if every human on Earth jumped at the same time, the result would be surprisingly anticlimactic. The Earth would move less than the width of an atom, and then move right back when everyone landed. Our planet wouldn't crack, shift, or even wobble. It probably wouldn't even notice. Which means humanity's greatest synchronized jump would be one of the most coordinated events in history, and one of the least important things the Earth has ever experienced.